Alright, so in this video we're going to solve a system of equations using the substitution method, okay? What I refer to as set equal. Alright, if you'll notice in my systems I've got two equations. This is what makes it a system of equations. Both equations are solved for y, okay? So with both equations being solved for y, I can use what's called the transitive property. Y is equal to both of these expressions, 3x minus 7 and 2x plus 2, okay? So because y is equal to both of those expressions, then I can set those expressions equal to one another, okay? So now I've got a simple little equation that just has one variable, x, and you have the tools to solve that, okay? So first thing we're going to do is subtract 2x from both sides, okay? And I'm going to simplify. So the 2x on the right side cancel out. On the left side, I'm left with x minus 7. On the right side, I'm left with 2, okay? And I want to get x by itself, so I'm going to add 7 to both sides, okay? So I get x equals 9, all right? Now we're not finished though, okay? That x equals 9 is just going to be half of my answer. Because when you solve a system of equations, you're going to get two solutions. You're going to get a solution for the x coordinate. You're going to get a solution for the y coordinate, okay? So I've got half my answer, x equals 9. I need to find the other half, what is y equal to. Now, how am I going to do that? I'm going to plug this x equals 9 into either one of these equations. You get to choose, okay? It doesn't matter which one you choose. If you found the correct value for x, you're going to get the same value for y when you plug it into either of these equations, okay? So I'm going to plug it into this first one, okay? So I'm going to rewrite this equation down here. I'm going to rewrite y equals 3x minus 7. I'm going to substitute 9 in for x. Okay, so I get y equals 3 times 9 minus 7. So again, using substitution here. And then I just simplify. 3 times 9 is 27. And I subtract and I get y equals 20. All right, so that's the other half of my answer. Now, I want to write my solution as an ordered pair, okay? And it's always going to be x comma y. So x comes first, 9. Y comes first, 20. And so the answer, the solution to this system of equations is 9 comma 20, okay? You can plug both those values into this equation. You're going to get a true statement as well, and you can always check your work. All right, so in this video, I'm going to, if you look at the equations, x is solved for in both of these. So we're going to work this with the same process. I just wanted to show you that you can do it whether x is solved for here or like in the first problem, y was by itself, okay? So we're going to rewrite both equations, okay? And we know because x is equal to both of these expressions, we can use the transitive property and we can write a new equation setting negative 4y minus 1 equal to negative 5y plus 6, okay? So again, we've got an equation here with one variable, which means we have enough tools to solve it, okay? I'm going to add 5y to both sides, okay? And they cancel out on the right side. The left side, I'm left with y minus 1. On the right side, I'm just left with 6. I'm going to add 1 to both sides, and that gives me y equals 7. Okay, again, that gives me half my answer. I need to find the other half. I need to find the x coordinate for my answer. So I'm going to plug into either one of these two. It doesn't matter, again, if this y equals 7 is correct. I'm going to get the same value whether I plug it here or whether I plug it here. Okay, so I'm going to go with the first equation again. All right, so let's plug in. I'm going to rewrite my equation. X equals negative 4y minus 1. I'm going to plug in 7 for y there, and then that'll help me solve for my x value. So when I plug in 7 for y, I get negative 4 times 7 minus 1, which is negative 28 minus 1, which is negative 29. So I've got the other half of my answer here. Remember, the x coordinate comes first, so my answer is going to be negative 29 comma 7, okay? Again, if you plug both those values, negative 29 in for x, 7 in for y, you're going to get a true statement here with both equations, okay? So that's how you solve a system of equations where both equations are already solved for the same variable.